Hello students, welcome back. Today this is your first class, online class. Today I am going to teach you haloalkanes and haloarenes. Haloalkanes and haloarenes are the organic compound which are derived by the replacement of hydrogen atom from alkane, it will form haloalkane, and from arene it will form haloarene. In haloalkane, the carbon to which halogen is attached is sp3 hybridized, whereas in haloarene attached will be sp2 hybridized. Now I am giving you the example of haloarene. Here the carbon is sp3 hybridized. Second, haloarenes, that is C6H5Cl. Now the carbon to which halogen attached is sp2 hybridized. About hybridization we have studied in class 11th. The importance of haloalkanes and haloarenes are: number 1, they are used as solvent. Number 2, the chlorine containing compound chloroamphenicol produced from microorganism is used to cure typhoid fever. It is a broad spectrum antibiotic. It can be used for many other microbial infections. Number 2, iodine containing hormone which is released in our body, that is thyroxine, it is used to cure goiter. Third is chloroquine, which is a very famous medicine for malaria treatment. And fourth is halothane, which is used to that is as a hypnotic, that is anesthetic, sleep inducing drug. Now we will start studying, that is classification of haloalkane and haloarene. First classification is on the basis of number of halogen atom. On the basis of number of halogen atom, they are classified as mono halogen derivative, that is one halogen atom is present in it. We can take the example of, that is CH3Cl, that is methyl chloride. If two halogen atoms are present, that is ethylene chloride, it is called dihalogen derivative. Likewise, if 3, it is trihalogen derivative, 4, tetrahalogen derivative, and so on. Now if we take in the case of arenes, we have if one halogen atom is attached, monohalogen, that is monobenzene. Second is mono dihalobenzene. If 3, trihalogen derivative, that is benzene. Now the molohalogen derivatives can be further classified on the basis of, that is hybridization. First is, that is sp3cx bond, that is the halogen atom attached is to the sp3 hybridized carbon atom, in which first is alkyl halide, that is CH3Cl. Now here it can be further classified into three. That is primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Now primary alkyl halide means that is one alkyl group is present with the halogen. For example, CH3Cl, C2H5Cl. If two alkyl groups are present, then it is secondary alkyl halide. For example, CH3 this is isopropyl chloride, or if three alkyl groups are present, then it is called tertiary alkyl halide. Now the general formula which we can use for this is CnH2n plus 1x. It is for haloalkanes. Now second, under this topic, second is allylic halides. Now what are allylic halides? Allylic halides are those halides in which the halogen atom is attached to sp3 carbon atom and adjacent to it is sp2 carbon atom, that is double bond should be present in it. For example, CH2 now you can see here this carbon is sp3 hybridized carbon and this is sp2 hybridized carbon. This carbon is allylic carbon. Second example we can see in cycloalkanes. Now in cycloalkanes, again this is the double bond present here, adjacent to it is sp3 hybridized and this carbon is sp2 hybridized. So this again this carbon is known as allylic carbon. Third, under it, third is benzylic halide, means in benzylic halide adjacent to the sp3 hybridized carbon, benzene ring is attached. Adjacent to the sp3 hybridized carbon, that is benzene ring is present. For example, now you can see here that this carbon is sp3 and just adjacent to it is benzene ring is present. So it is called benzylic halide. This can be of three types, again primary, secondary and tertiary. With at the sp3 carbon, one more alkyl group is attached with the benzene ring, then it is called secondary benzylic halide. This is one first alkyl group, this is benzene ring, this is secondary one. In tertiary alkyl halide, two alkyl groups and one benzene ring is present, then it is tertiary benzylic halide. Now, on the basis of the that is hybridization sp2c bond, again they are classified into two. sp2cx bond. They are of two types. First is vinylic halides. Under vinylic halides, vinyl group is present, and second is aryl halides. One more example we can take here under vinylic halides. Now, under aryl halides, halogen atom is directly attached to benzene ring. So, they are haloarenes. They are also called as haloarenes. Here, the carbon attached is sp2 hybridized. Similarly, here also the halogen attached is as sp2. Here also the halogen attached is sp2 carbon. So, under the class one sp2cx bond, two examples are, one is vinylic halide and second is aryl halide. Now, next topic is IUPAC, naming of the haloalkanes and haloarenes. General rules for IUPAC naming we have studied in class 11th. Some of the rules which I will like to repeat or refresh to you. First rule is choose the longest possible carbon chain. Second rule is that naming should be done from that side from where the functional group get the lowest preference. Third, we should have the preference order on the, that is, first preference order should be given to functional group, second to double bond, third to triple bond, and then to substituent group. Now, in IPSC system, the first example we will take is this is the common simplest example of this. Now here you can see that only one carbon is present, so it is numbered as 1, and for 1 we write down methane, and Cl is attached to it, so prefix chloro will be used. So common prefix which is used is haloalkane, that is why it has got the name haloalkane. Second example you can take, that is CH3, CH, Cl, CH2, CH3. Now here we can take the example of preference order, that is 1, 2, 3, 4. So you can see here that at second position Cl is attached and 4 carbons are present here. So we will write down butane, and at second position Cl is attached, so 2-chlorobutane. Similarly, we can take the example, if suppose double bond is also present here, if double bond is also present, CH3CH double bond CH CH Cl CH3. Now here we should take care of the preference order rule, that is, if we will number from this side, it will be 1, 2, 3, 4, 5. If you will number from, that is 1, 2, 3, 4, 5, and if from this side, then it is 1, 2, 3, 4, 5. Now you will see that the preference order for double bond from the top end we get 2, and from lower end we get 3. So the lower end will be wrong and the top one will be right. So we can write down, that is 4-chloro, 4-chloro, but 1, 2, 3, 5. It will be pent 2-ene, pent 2-ene. Now again in IUPAC sometimes we have 2 halogen atoms present in the organic compound. At that time the naming in naming commonly we use the terms gem and vicinal. If both the halogen atoms are present at the same halogen atom, then it is called gem dihalide, and if it is present at the different halogen atom, then it is called vicinal dihalide. For example, now you can see here both the halogen atoms are at different carbon atom, so it is called vicinal dihalide. So while writing common name, we will write down vis 1 2 dichloroethane. In the case if both the halogen atoms are present at the same carbon atom, then term geminal dihalide. So we write down the prefix gem 1 1 dichloroethane, and these two are collectively called as alkylidene chloride, alkylidene chloride, or alkylene dihalide, alkylene dihalide. We can take some more examples. For example, CHBr3. Commonly it is known as bromoform, but IUPAC, you can see here that 3 Br are attached to the single carbon. So it will be named as one tribromomethane. Now we will take some examples of haloarenes. Now it is called as halobenzene. Halobenzene. Now while writing the IUPAC naming in haloarenes, in IUPAC we use the digits 1 2 3 4 5 6. Position 1 and 4, they are called para positions, but not used in IUPAC name. 2 and 6, they are called ortho. 3 and 5, meta. Again, we know that it is a substituent group. So if suppose other than halogen we have other functional group like OH, alcohol group, so the preference order will be given to alcohol, that is OH, its name will be, and this halogen will get the second preference, so it will be used as prefix. So, its number that is 2 halophenol. Likewise, many more examples we can take. Next, you can practice from your NCERT book. Next is, that is nature of CX bond. Now, we know that halogen atoms are electronegative in nature. So, when they are attached to the alkane group, then the bond gets polarized This is the alkyl halide. The simplest one is methyl halide. Now you can see that X halogen is more electronegative. It will attract the bond pair towards itself and thereby it will acquire partial negative charge and the carbon will acquire partial positive charge. So, due to that this bond becomes polarized. Now, as we move from fluorine to iodine, we will see that the size of the halogen atom increases and due to which the bond length of CH3F2 CH3I increases, and when the bond length increases, then bond dissociation energy decreases, and that is why alkyl halide under alkyl halide alkyl iodides are more reactive. If we will consider about the dipole moment of CH3Cl is highest, then CH3F, then CH3Br, then CH3I. So, as we move down the group, electronegativity decreases, but here you should take care that sometimes in the exams it is asked to arrange them order in the increasing order or decreasing order of dipole moment. So, generally we do mistake in this. So, always consider that CH3Cl has the highest dipole moment. Now, we will study the method of preparation of haloalkanes and haloarenes. Now, the method of preparation of haloalkanes we will study from, that is alcohol. There are many methods from which haloalkanes can be prepared. We will study one by one. The first method is alcohol. Alcohol when reacts with anhydrous zinc chloride and HCl, it forms RX plus your RCl plus HC. This anhydrous zinc chloride plus HCl is known as Lucas reagent. Second is when it reacts with NABr plus H2SO4, it forms RBr plus NeHSO4 plus H2. We know that sulfuric acid forms two series of salt. Third is when alcohol reacts with PCl3, again it forms RCl plus H3PO3, that is hypophosphorus acid. If it reacts with PCl5, then it will form RCl plus POCl3 plus HCl. Now you can see here कि whenever any compound, here we have taken alcohol, but suppose it is carboxylic acid or any other compound, if it reacts with PCl3 and PCl5, the byproduct H3PO3 in the case of PCl3 and POCl3 plus HCl in the case of PCl5 remains same. And the last and the most beneficial method is when alcohol reacts with thionyl chloride, SOCl2. It forms alkyl halide, that is RCl plus SO2 plus HCl. Now why it is beneficial method? Because these two products are gaseous in nature, they escapes out. Now the order of reactivity of alcohol is tertiary alcohol order of reactivity of alcohol is tertiary is more reactive than secondary and then primary. Now by this method, that is from phenol, we cannot prepare haloarenes. Yes, haloarenes cannot be prepared from phenol because in phenol, due to resonance, it acquires double bond character, which is difficult to break. Now you can see in this resonating structure that this O and C, it acquires double bond character, so that is why it is difficult to break. Very important question, it is asked in board कि why haloarenes cannot be prepared from phenol. Second method of preparation is for free radical mechanism. Second method, that is preparation of haloalkanes by free radical mechanism. When alkane reacts with chlorine and sunlight, it forms one chlorobutane and two chlorobutane. So this method is not preferable method because in this method we get mixture of haloalkanes. So this method is not used. Now third method is from alkenes. Now in symmetrical alkenes no problem, but in unsymmetrical alkenes we will take care of Markovnikov's rule. So from alkene, first is that is addition of HX. So when ethene reacts with HX, it forms CH3 CH2X. But if it is unsymmetrical alkene, we have to take care of Markovnikov's rule. In Markovnikov's rule, the negative part of the reagent goes to that carbon atom which has least number of hydrogen atoms. So X will go to the CH part and it will form CH3 CH X CH3. So once again I am repeating, the negative part of the reagent goes to that carbon atom which has less number of hydrogen atom. Now again here two bifurcations are there. If it is in place of X, if it is Cl, then no problem, this rule will be there. But if it is HBr, then we use the rule that is anti-Markovnikov's rule, and it is just opposite of Markovnikov's rule. That is, the negative part will go to that carbon atom which has more number of hydrogen atoms, and that reaction takes place in the presence of peroxide. So that is also called as peroxide effect or Kharash effect. So two rules we have studied in here. What is that? Markovnikov's rule and anti-Markovnikov's rule. Markovnikov's rule just now I have explained. Now I will explain the anti-Markovnikov's rule also. CH3 CH2 plus HBr in the presence of peroxide, that is benzoyl peroxide. It forms CH3, CH2, CH2, Br. Now, from alkenes, second method is addition of halogen. Now, this reaction can be used for detection of unsaturation in organic compound, also called as bromine water test. So, if we add bromine water in any unsaturated compound, then the pink color of bromine water gets discharged, that is gets colorless. Now, again next method is halide exchange method. Next method, that is fourth method, halide exchange method. Halide exchange method, first is Finkelstein reaction. Under first is Finkelstein reaction. Finkelstein reaction, when R X reacts with NaI in the presence of dry acetone, it forms Ri plus NaX. So, you can see here that exchange of halogen has taken place. The function of dry acetone is to precipitate the NaX formed here. The function of dry acetone is to precipitate the formation of NaX, that is NaCl or NaBr. Second under it is Swartz reaction. This is the only method for preparation of alkyl fluorides or fluoroalkane. In this method, the alkyl halide reacts with AgF or COF2 or HgF2, then fluorine atom gets displaced, or fluorine atom displaces the other halogen atoms. CH3Br plus AgF will form CH3F plus AgBr. This reaction is called Swartz reaction. Next is method of preparation of haloarenes. Now, in haloarenes, it can be prepared by electrophilic substitution reaction. Haloarenes, These haloarenes can be prepared by electrophilic substitution reaction. We can take the example, that is when Cl2 reacts with anhydrous FeCl3, it generates an electrophile Cl+. This electrophile attacks the benzene ring. Now, toluene reacts with Cl2 in the presence of anhydrous FeCl3. It forms orthohalotoluene and para-halotoluene. These two can be separated by fractional distillation because there is a large difference in their boiling point. Now, if in this reaction iodine is taken, then the reaction becomes reversible, means again it will return back. So, to make it irreversible, we add oxidizing agent like HiO3 or HNO3, and these two are added to make the reaction irreversible. So that the Hi formed will not converted back to iodine again. Now, fluoroarenes cannot be prepared by this method because of the superreactivity of fluorine atom. Fluoroarenes cannot be prepared by this method because of the superreactivity of the fluorine. Is also called as superhalogen. Now, next method is preparation of haloarene by Sandmeyer's reaction. Now, Sandmeyer's reaction is the method of preparation of haloarenes in the presence of CuCl/HCl from benzene diazonium chloride. Now, how to prepare benzene diazonium chloride? Sandmeyer's reaction. Now, when aniline reacts with nitrous acid plus now this nitrous acid is prepared from NaNO2 plus HCl, sodium nitrite plus hydrochloric acid. Now temperature should be between 0 degree centigrade to 5 degree centigrade to form benzene diazonium chloride. Now if temperature rises above 5 degree centigrade, this benzene diazonium chloride becomes unstable. So to make it stable, the temperature should be between 0 degree to 5 degree centigrade. This step is known as diazotization. This step is known as diazotization. And this, when benzene diazonium chloride reacts with CuCl/HCl, it forms chlorobenzene. If we want to prepare C6H5Br, we can take CuBr/HBr. Now, if we want to prepare C6H5I, then benzene diazonium chloride can be simply shaken with Ki. No other reagent is required. It will form iodobenzene. Now, today in this session, we have learned, that is, classification of haloalkanes and haloarenes, IUPAC naming of haloalkanes and haloarenes, then nature of bond, and method of preparation of haloalkanes and haloarenes.